Hi guys, my name is Peter C. Dogba Jr., math instructor at the University of Liberia and your math tutor. In today's lecture, I will be looking at trigonometry, and particularly I will be finding the values of trigonometry functions using the right triangle. So when the triangle is not a right triangle, then it means that we have to use either the sine laws or the cosine laws to find the values of the missing sides of that triangle, or to find the missing angles of the triangle. But for this case, we want to just use the different definitions of the trigonometry functions to apply them given a right triangle. So in the previous video, we did the definition of the trigonometry functions. So we want to use those definitions now, to solve some problems. So let's look at this triangle. Consider that you have a right triangle. Okay, I'm not too perfect. Okay, so consider that you have this to be a right triangle. And we know that a right triangle, a triangle in general has three sides. It's a closed geometric figure. It has three sides. Any triangle has three sides. The sum of the angles within a triangle is equal to 180 degrees. So a triangle is considered a right triangle if it has one 90-degree angle. And that 90-degree angle is shown from this symbol. So as long as you see this symbol like this, it means this angle measures 90 degrees. So most times it is not indicated, but the symbol represents 90 degrees. So assume that we have this side to be 4 units, this side to be some 3 units, this side is unknown, and you have A, B, and C. So each of these angles can represent like values within it or Greek letters. They can also represent 3 letters, right? Considering 3 points. So we could name this particular angle C. We could call it angle ACB. So the traditional way is that the actual angle that you are naming is in the center between the 2 other points. So if we want to name this angle B, we will say angle CBA. So CBA. So it is this angle we're referring to. We could also say angle ABC. So we're still referring to this particular angle because it is in the center of it. So we could also call this angle theta, this particular angle. So now we know that we have this right triangle, and we were asked to find a sine of B. The first one says we must find sine of B. So how do we find sine of B? What do we know of sine of B? From our previous lecture, we know that sine is defined as the opposite side divided by the adjacent, or divided by the hypotenuse. So the opposite side to an angle is the side directly facing that angle. So this is the angle. So the side directly facing this angle is this line. So this is considered the opposite side to angle B. If you left from angle B and went at angle A, so we will know that the opposite side to angle A is 3, is this side, because this side is directly facing this angle. The side, the side beside the angle, right? Or the side of the angle. That is, this is the angle. If you just take this angle from here, the angle is like this. This is the angle. So this is one side. This is another side. So this side is called the side of the angle. Now, this one, because this one is the longest side, it has a definite name called the hypotenuse. So it is never the opposite side, neither the adjacent side. Okay. Now, let's find sine of angle B. So we could say sine of angle B. We could also say sine of angle theta. So we know that it is opposite side. What is the opposite side to angle B? The opposite side is 4. What is the hypotenuse? The hypotenuse is not known. So we could say let this be some C. So if there is capital C, let the side opposite capital C be some small c. If this is capital B, let the side be small b. And if this is capital A, let the side be small a. So this is B. Now, so how can we find this value? Because we need the hypotenuse. So we can say, let's use the Pythagorean theorem. So by means of the Pythagorean theorem, we know that the square of the hypotenuse is equal to the square of the sum of the legs. So the square of the hypotenuse is equal to the sum of the square of the legs. So this is 1, this is 1. So you square these two, you add them, it gives you the sum of this hypotenuse. So now, since we are solving for C portion, we can now put in the value for B and put in the value for A. So we know that A is 3. So we have C squared equals to 3 squared plus this B is now 4. So it's 4 squared. So C squared equals, now 3 squared means 3 times 3 plus 4 squared means 4 times 4. So 3 times 3 is 9. 4 times 4 is 16. So 9 plus 16 is just equal to 25. Now we want to find the square root of 25. So we take the square root on both sides. So now this square root will cancel these 2. The square root of 25, which number can you multiply 2 times? The same number that you multiply 2 times will give you 25. So we know that 5 times 5 equals to 25. Therefore, we can rewrite this as 5 raised to the second power. So if you put this in, 5 raised to the second power, and then you square it like this, this 2 will cancel the square root. So C now will be equal to plus or minus 5. Now the reason why we say plus or minus 5 because positive 5 times positive 5 will give you positive 25. Negative 5 times negative 5 will give you positive 25 as well. So this can be minus 5 raised to the second power. So if you take the square root of it, this will cancel, you'll be left with negative 5. So the value of C is negative 5 or positive 5. Now, since we are now dealing with the distance from A to B, we know that distances are never negative. So therefore, we are going to get rid of this negative 5 and select positive 5. So now we have the value of the 3 sides, 3, 4, and 5. So the opposite side now to angle B is 4. So this is 4. And the hypotenuse is 5. So sine of B is equal to 4 over 5. So we do the next one. The next one says we must find cos of A. So cos of A, this is A. We stand at A. What is cos definition? Cos definition is adjacent side all over hypotenuse. So the adjacent side to A, this angle A, is the side that is beside angle A, which is 4. So it's now 4. The hypotenuse is 5. So it's 4/5. Now, what if we find cos of theta? Now, cos of theta is the same as saying cos of B. So again, we define cos of an angle. The definition of cos is adjacent side all over hypotenuse. So what is the adjacent side to this angle? The adjacent side to this angle is 3. And the hypotenuse now is 5. So what if we do tangent of A, for example, as well? Tangent of A. So tangent of A, which is this angle now, we know that tangent is defined as opposite side divided by adjacent side. So which side is the opposite side? The opposite side to angle A is the side that is before angle A. So this side. So it's 3. And which side is the adjacent side to angle A? Is 4. So it's 3/4. What if we were to find tangent of angle B? So tangent of angle B, we take the opposite side now, which is 4. And then the adjacent side, which is 3. So the opposite side at this angle will be the adjacent side at this angle. What if we find what is cot of B? So we know that cot of B, cot definition we know from the previous lesson. We know that cot is equal to adjacent side all over the opposite side. So what is the adjacent side to angle B? This is angle B. The adjacent side is 3. And what is the opposite side to angle B? Is 4. So we can clearly see that tangent of B, which is 4/3, and cot of B, which is 3/4. So it means that it was true when we say tangent inverse. The reverse of tangent definition is also referred to as cot. So tangent inverse is cot. So let's find what is tangent of B when tangent is being defined as sine of B all over cos of B. Remember we told you in the previous lesson that tangent is equal to sine of B all over cos of B. So let's look at it. So what is sine of B? So we did sine of B right here. Sine of B is 4/5. So we would now have tangent of B in the numerator is 4/5. And in the denominator, what is cos of B? So we did not find cos of B, right? So we can say cos of B, this is B. So cos is adjacent side. So this is adjacent side, which is 3. And in fact, we found cos of B because cos of theta is the same as cos of B. So we found it to be 3/5. So this is 3/5. Now this is a complex fraction wherein you have fraction in the numerator and fraction within the denominator. So we can simplify tangent of B. So we say tangent of B is equal. We take the numerator fraction 4/5. Then instead of writing this division line, which of course we could write the division line and rewrite the fraction, but we don't want to go that long way, so we change the division sign, or if you want in the next step we can just do that. So this is now 4 over 5. So we change the division sign now to multiplication. And then we reciprocate the second fraction. So this fraction, we turn it around, right? Like saying 5 in the numerator and 3 goes down in the denominator. So it's 5 over 3. So what do you observe? 5 can cancel 5. So we're left with 4 over 3. So tangent of B is equal to 4 over 3. And tangent of B, which is also sine of B or over cos of B, is 4 over 3. So that's the reason why we said tangent is equal to sine over cos. And cotangent is equal to cosine or over cos. Additionally, let's do the last one. Secant. What if we want to find secant of angle B? So we know that secant is equal to hypotenuse, right? Hypotenuse all over adjacent. So which side is the hypotenuse? This is 5. And which side is the adjacent to angle B? It's 3. But the secant definition, which is the reverse of cos, can also be written as secant of B is equal to 1 all over cos of B. So if you turn it around, you have the reverse. So now we have secant of B to be 1 divided by, now what is cos of B or cos of theta? It was 3 over 5. So this is 3 over 5. So again, we apply the fraction simplification. Secant of B is equal to 1 divided 3 over 5. So we can change this sign now to multiplication and reciprocate the second fraction. So it's 5 over 3. So this is just equal to 5 over 3. So we can clearly see that tangent of B, which was derived yet to be 5 over 3, is the same as tangent of B, which we rewrite as 1 over cos of B. So sine of an angle, the inverse of that trigonometric function sine is cosecant. The inverse of cosine is secant. The inverse of tangent is cotangent. So thanks ever so much for watching. Please don't forget to subscribe to our YouTube channel and see you in our next lecture. Thank you.